example number 6, find the particular solution of the following differential equation. Here in the miscellaneous exercise there are 5 examples are done. Now the example number 6, it is a find the particular solution of the differential equation. In the differential equation, solution of the differential equation, there are the two types. It is a general solution and there is a particular solution. Okay, the examples of the general solution we see in the last lecture. Now we see the particular solution of the differential equation. Here, find the particular solution of the differential equation. There is a question number 1 here. Y into 1 plus log x is equal to log of x to the power x into dy by dx. When y of e is equal to e square. Now we want to find the particular solution when y of e is equal to e square. Now here it is a given differential equation. Given differential equation is, it is y into 1 plus log x is equal to log x to the power x into dy by dx. Now we solve this differential equation by using the variable separable method. Now here it is a first separate the differential coefficient and then the variables. The all variables of x write with x and all variables of y write with y. Okay. Now we write x here. Therefore see carefully. Here it is a y into 1 plus log x dx is equal to, here log of x to the power x, this can be written as x into log x into log x into dy. See carefully, we can write only this dx in the LHS, and here log of x to the power x, here we use the property of the logarithm. We take this power in the multiple of this log x into log x. Now it is a dx, so the function of x we write with dx, and here it is a y, we write with dy. See carefully this. Therefore we get it is a 1 plus log x upon x into log x dx is equal to 1 by y dy. Now the variables are the separated, so we integrate this. Then integrate both sides. 1 plus log x upon x into log x with respect to x is equal to integral of 1 by y dy. See carefully. Now here it is a 1 by y with respect to y. It is clearly integration is a log y. But here 1 plus log x and upon x into log x. Now here see clearly it is x into log x. The derivative of x into log x, it is 1 plus log x. Okay. Here see carefully. Here derivative of x into log x is equal to x into 1 by x plus log x into 1. See carefully this. First as it is derivative of the second, second as it is derivative of the first. That means here it is a 1 plus log x. Okay. Now that means numerator is a derivative of this denominator. Here f dash of x upon f of x, and now integral of f dash of x upon f of x, it is log of f of x. Therefore we can directly write log of x into log x is equal to log y and plus integral constant also is in a log, because all integrals are in the log. Therefore integral constant we can write in the logarithm. Now here therefore log of x into log x is equal to log of y into c, removing log on both sides. Therefore x log x is equal to y into c. Here is the general solution of differential equation. Okay, here it is a general solution, but we want to find the particular solution when y of e is equal to e square. Now when y of e is equal to e square, y of e is equal to e square, that means when x is equal to e, y is equal to e square. Now the general solution is x into log x, x into log x is equal to y into c. Therefore x e into log x log e is equal to y square into c. X log x, y c, x log x, and it is y into c. Then we get here e log e is equal to 1, then e square into c, and therefore c is equal to, here it is e get cancelled 1 by, here e is equal to e square c, e get cancelled, 1 is equal to e into c, that means c is equal to 1 by e. It is the value of c, and therefore the particular solution is, it is x into log x is equal to y into c, and c it is a 1 by. Okay. Here it is a particular solution, or we can write it is e into x log x is equal to y. It is a particular solution of this differential equation. See carefully, e x into log x is equal to y, that means y equal to e into x log x. It is a particular solution. Okay. Now we see the second example. Example number 2. X plus 2y square dy by dx is equal to y when x is equal to 2 and y is equal to 1. Now, the given differential equation x plus 2y square dy by dx is equal to y. It is a given differential equation. See clearly here, when we separate the differential coefficient dx and dy, but we cannot be separate the variables x and y. That means it is not in the variable separable form, and it is also not a homogeneous differential equation, because here degree it is 1 but here degree it is 2. It is not homogeneous differential equation. Now we check it is a linear differential equation or not. Okay, when it is a linear differential equation in y, that means the degree of dy by dx and degree of y, it is 1. That means the power of the dy by dx and power of the y, it is 1. Here the power of the dy by dx it is 1, but the degree of the degree of the y, not 1, it is a 2. Degree of y it is a 2, and degree of dy by dx it is 1. That means it is a not linear differential equation in y. Now we try to check it is a linear differential equation in x or not. That means we write the dx by dy form. Okay, here we write one more step. Therefore here it is x plus 2y square is equal to y into dx by dy. Here dx by dy, and now here it is a linear differential equation in x. Linear differential equation in x, here the power of the dx by dy it is 1, and the power of x is also 1. Here the power of the dx by dy it is 1, and the power of x is also 1. Now we write this differential equation in the form of the linear differential equation in x, that is dx by dy plus px is equal to q, where p and q are the functions of y, okay, because it is a linear differential equation in x. Okay. Now see carefully this. Therefore dx by dy is equal to x plus 2y square upon y. This y we can write in the denominator, and then here it is a x by y plus 2y. See carefully, dx by dy is equal to this, and then dx by dy minus 1 by yx is equal to 2y. This x upon y we can write here. It is x upon y. Okay, it is right 1 by y into x, or write x by y. Okay, it is x by y. We can write in the minus, and now it is a linear differential equation in x. Compare with linear differential equation dx by dy plus px is equal to q. Okay. Here p is equal to minus 1 by y and q is equal to 2y. Now to solve this linear differential equation, first write the integrating factor. Therefore the integrating factor is equal to e to the power integration of p dy is equal to e to the power integration of minus 1 by y dy, that is e to the power minus log y. Here minus and 1 by y, integral of 1 by y, it is log y. That means e to the power log of 1 by y. That means 1 by y, it is an integrating factor. Integrating factor, it is 1 by y. Now the solution of the linear differential equation. Therefore solution of linear differential equation in x is integrating factor into x is equal to integration of integrating factor into q with respect to y. Now put the values. Integrating factor, it is 1 by y. 1 by y into x is equal to integration of integrating factor, it is 1 by y into 2y, it is a q with respect to y. Only we put the value of the integrating factor, it is 1 by y, integrating factor, it is 1 by y, and it is q, it is a 2y. Now here it is a x by y is equal to integral of 2 dy, because this y get cancelled, this y and this y cancel, we get only 2. Here integrating factor, it is 1 by y, and q, it is a 2y. Integrating factor into q, it is 1 by y into 2y. Y get cancelled, only remaining 2. And then the integration is x by y is equal to 2y plus c. See carefully. Here it is an integral, that is general solution. Is general solution of the differential equation. Now when x is equal to 2 and y is equal to 1, we find the particular solution. When x is equal to 2 and y is equal to 1, 2 into 1 plus c, and therefore it is a 2 is equal to 2 plus c, and therefore c is equal to, it is a 0. Okay. 2, then c is equal to 0, therefore the solution, it is x by y is equal to 2y. It is a particular solution. We write the particular solution. Therefore particular solution of given differential equation is x by y is equal to 2y plus 0, 0 it is the value of c, and that is x is equal to 2y square is the particular solution of this differential equation. See carefully this. Okay. Now we see the next example. Now the next third example, dy by dx minus 3y cot x is equal to sin 2x when y of pi by 2 is equal to 2. Now the given differential equation, it is a dy by dx minus 3y cot x is equal to sin 2x. Now here it is clearly in the form of the linear differential equation in y. Here dy by dx plus py is equal to q, linear differential equation in y. Compare with the linear differential equation dy by dx plus py is equal to q. Therefore p is equal to, see carefully, p is a coefficient of the y, and the coefficient of y here it is a minus 3 cot x, and q is equal to, it is a sin 2x. Now here first find the integrating factor. Therefore the integrating factor is equal to e to the power integration of p dx. See carefully, e to the power integration of minus 3 cot x with respect to x, and the integration of the cot x here e to the power minus 3 as it is, and integration of the cot x, it is a log of sin x. Here integration of cot x, it is a log of sin x. Therefore our integrating factor, we can write here, it is e to the power log of sin x to the power minus 3. Okay. And that means sin x to the power minus 3, it is an integrating factor. Integrating factor, it is e to the power minus 3 log of sin x. Minus 3 we write in the power of the sin x. Therefore here, and here sin x to the power minus 3, that means 1 upon sin cube x, and it is an integrating factor, 1 upon sin cube x, it is an integrating factor. Now solution of this linear differential equation, therefore solution of linear differential equation in y is integrating factor into y is equal to integral of integrating factor into q with respect to x. Now here integrating factor, it is a 1 upon sin cube x into y is equal to integral of 1 upon sin cube x into sin 2x dx. See carefully this. Okay. Now we want to find the integral of this. Here it is a 1 upon sin cube, and here it is a sin 2x. Angle here it is a x, and here it is a 2x. So first we use here the trigonometric formula for the angle 2x. Okay, sin 2x. Now here it is a y upon sin cube x as it is into integral of, here it is a 2 sin x into cos x upon sin cube x with respect to x. See carefully this. Y upon it is a sin cube x, and it is a 2 sin x into cos x. It is a formula for the sin 2x. Now sin x get cancelled. 2 cos x upon sin square x. Okay, here we write here, therefore y upon sin cube x is equal to integral of 2 cos x upon sin square x dx. Now to find the integral, here it is a cos x in the multiple of the dx, and cos x is a derivative of the sin x, so we put sin x is equal to t. Okay, here we use the substitution, put sin x is equal to t, and therefore cos x dx is equal to dt, and then our integral is y upon sin cube x is equal to, here it is a 2 into integral of 1 by t square with respect to t. It is a 2 as it is, cos x dx it is a dt, it is 1 by t square. Now here 2 into integral of t to the power minus 2 dt, 1 by t square, it is a t to the power minus 2. Now integral is 2 into t to the power minus 1 upon minus 1 plus c, and that is, it is minus minus, it is a 2 upon t, it is a minus 2 upon t, see carefully, it is minus 2, and t to the power minus 1, it is a 1 by t, and plus c, it is integral of this, and then put the value of c, put the value of it is a t, sin cube x, sin cube x is equal to, it is a minus 2 upon sin x plus c. Here is the general solution of the differential equation. Okay, here or we multiply by sin cube x, we get y, therefore multiply by sin cube x, y is equal to multiply by sin cube minus 2 sin square x plus c into sin cube x. Here is the general solution of differential equation. Now we want to find the particular solution when y of pi by 2 is equal to 2. Now when y of pi by 2 is equal to 1, y of pi by 2 is equal to 2, that is x is equal to pi by 2 and y is equal to 2. Here y of pi by 2 means x is equal to pi by 2 and y is equal to 2. Therefore 2 is equal to minus 2 into sin square pi by 2 plus c into sin cube pi by 2. We know that sin pi by 2 it is 1, therefore 2 is equal to minus 2 plus c, and therefore c is equal to 4. Okay. It is 1, it is also 1, minus 2 is equal to c, and therefore the particular solution it is y is equal to minus 2 sin square x plus 4 sin cube x. Here it is a particular solution, that means 4 sin cube x minus 2 sin square x, it is a particular solution of this differential equation. Okay. Now we see the next example, see carefully this. Next example, x plus y dy. Example number 4, x plus y dy plus x minus y dx is equal to 0 when x equal to 1 equal to y, that means value of x and y are 1. Now here given differential equation it is x plus y dy plus then we write this equation in the dy by dx form, x plus y dy is equal to minus x minus y dx. And here when we write dy by dx, x minus y upon x plus y, it is equation number 1. And here it is a homogeneous differential equation. X, y, here same degree, same degree. It is a homogeneous differential equation. And here homogeneous differential equation we write in the form of the dy by dx. So here put y by x is equal to phi. Okay. Now put y by x is equal to phi. That means y is equal to phi x, and therefore dy by dx is equal to phi plus x into dv by dx. Then equation 1 becomes dy by dx, it is this, phi plus x into dv by dx is equal to minus x minus x phi or phi x, it is y, upon x plus x phi. Then this x get cancel, x take common and take cancel. Then here it is a minus 1 minus phi upon 1 plus phi. See carefully this, x plus x dv by dx, it is minus x get cancelled, we get this. Now this phi we can write in the RHS, that means minus x dv by dx is equal to, it is minus 1 plus phi, minus 1 plus phi upon 1 plus phi and minus phi. See carefully this, it is v, we can write in the minus. Then take the calculation, it is a minus 1 plus phi, minus 1 plus phi, it is minus 1 and it is a plus phi. Then multiply by this, minus phi square. Then here it is a minus phi square upon 1 plus phi. Okay. Then it is a x dv by dx, separate the differential coefficient, therefore it is a x dv is equal to, here phi get cancelled, minus 1 minus phi, it is minus 1 plus phi square upon 1 plus phi dx. See carefully this. Okay. Here phi get cancelled, minus 1 and it is a minus phi square, we take minus common, it is 1 plus phi square upon 1 plus phi, x dv, and here it is a dx. Now this x take in the RHS and this term of the v we write with phi. Then 1 plus phi upon 1 plus phi square dv is equal to 1 by x dx. Only we separate the variables. X we can write RHS and it is 1 plus v square upon 1 plus v we write in the LHS. Now separate the variables taking integral. Is equal to integral of 1 by x dx. Now here it is a linear function upon the quadratic function. Linear function upon quadratic function, and we know how to find the integral of the linear function upon the quadratic function. We adjust the derivative of the quadratic function in linear function, and here the derivative of this quadratic function, that is 1 plus v square, the derivative of 1 plus v square, it is a 2v. We adjust 2v in the numerator. See carefully. Here it is we can write 2v, but originally here only v, therefore we can write 1 by 2 and plus 1 upon 1 plus v square dv is equal to integral of 1 by x dx. Now separate the integrals. It is 1 by 2 into integral of 2v upon 1 plus v square plus 1 upon 1 plus v square. Okay, it is 1 by 2 only for this integral. Here we separate the integral and separate the denominator. Okay, here 1 by 2 only multiple with 2v, so this multiplier, it is dv plus integral of 1 upon 1 plus v square dv is equal to integral of 1 by x dx. See carefully this. Okay, here it is a minus. Here it is minus. Okay. Now here we separate 1 by 2 only multiple with 2 phi and it is 1. We separate this denominator and separate the integral. Now take the integral 1 by 2 into f dash of phi upon f of phi. It is log of f of phi plus 1 upon 1 plus c square. It is a standard integral. Tan inverse of phi is equal to minus log x and plus c. Here it is an integral. Now put the value of phi. Then 1 by 2 log of. Okay, 1 by 2 means under root. Okay, here this 1 by 2. You can write it is a log of under root 1 plus phi square, and phi it is a y square upon x square. This 1 by 2 we can write in the under root plus tan inverse of y by x is equal to minus log x plus c. Now take the calculation. Log of under root x square plus y square upon x square plus tan inverse of y by x is equal to minus log x plus c. Now this log separate. It is a numerator and denominator. Here we use the property log of a by b. Log a by b, it is a log a minus log b. Then it is numerator log of under root x square plus y square minus log of under root x, it is x, plus tan inverse y by x is equal to minus log x plus c. Then here it is a minus log x get cancelled. Log of under root x square plus y square plus tan inverse of y by x is equal to c is general solution. Okay, here is general solution of differential equation. Okay, now when x is equal to y is equal to 1, then put the values. Therefore log of under root 1 square plus 1 square plus tan inverse of 1 by 1 is equal to c, and therefore c is equal to, see careful this, here it is a tan inverse of 1, that is pi by 4, and it is a log 2, that means here it is a pi by 4 plus log 2. It is a log 2, 1 plus 1, it is a 2, sorry, under root 2, log of under root 2, and it is a tan inverse of 1, it is a pi by 4, it is a value of c, and therefore the particular solution it is here. It is a general solution. Log of under root x square plus y square plus tan inverse of y by x is equal to this pi by 4 plus log under root 2 is the particular solution. Only we write the value of c. This is c. Okay, when x is equal to 1 and y is equal to 1. Okay, it is x square plus y square. 1 square plus 1 square, it is a 2. That means log under root 2, and tan inverse of 1, it is a pi by 4. Therefore pi by 4 plus log under root 2, it is value of c. And now we put the value of c in this general solution, and therefore it is a particular solution. Log of under root x square plus y square plus tan inverse of it is tan inverse of y by x is equal to pi by 4 plus log of under root 2. It is particular solution of this differential equation. Now you see the last example in this question number 6. See carefully this. Last example. 2 into e to the power x by y dx plus y minus 2x e to the power x by y dy is equal to 0 when y of 0 is equal to 1. Now here the given differential equation, it is a 2 e to the power x by y dx plus y minus 2x e to the power x by y dy is equal to 0. Okay, here now here e to the power x by y, e to the power x, it is a standard function in x, or e to the power y, it is a standard function in y, but it is e to the power x by y. Okay, in the power there are the two variables which are not separated, so we put these two variables in one variable form by using the substitution. That means here we use the substitution, x by y is equal to u or v. Here we use the put x by y is equal to u. Okay, now here we put x by y, so we write this differential equation in the form of the dx by dy. Okay, here therefore 2 e to the power x by y dx is equal to minus y minus 2x e to the power x by y dy. We put x by y, so this differential equation we can write in the form of the dx by dy. Therefore it is a dx upon dy is equal to minus y minus 2x into e to the power x by y upon 2 e to the power x by y. Okay. Now it is our differential equation. We put x by y is equal to phi. Now here put x by y is equal to phi, that is x is equal to phi y. Okay, here we differentiate with respect to y, therefore we get dx by dy. Here we want dx by dy, so we differentiate with respect to y. Here phi into derivative of y with respect to y, it is 1, then y as it is, derivative of phi with respect to y, then with respect to y, then this equation number 1 becomes equation 1 becomes here dx by dy, it is phi plus y into dv by dy, okay, y into dv by dy is equal to minus y minus 2x, x it is a vy, into e raised to v upon 2 e raised to v. See carefully this. Okay. We put only x is equal to phi x and dy by dx is equal to y plus, sorry, it is phi plus y dv by dy. Okay. Now we get two variables phi and y. Okay. Here now this phi we can write in the RHS. Therefore y into dv by dy is equal to minus y minus 2vy e raised to v upon 2 e raised to v minus phi, this minus phi. Okay. Now the calculation it is minus y minus 2vy e raised to v minus 2v e raised to v and upon 2v e raised to v. Okay. Now y dv by dy is equal to this. Okay. Now see carefully this. It is y 2vy 2v raised to v. Now something wrong in this problem, because here the variables are not separated. Here it is y but here it is not y. Okay. Okay, something print mistake in this example. Why this y? Now here we modify this question. It is a 2y. See carefully. Here we write y. 2y e raised to x. Here we write y. Here we write y. And then for here it is y. 2y. Okay. Now it is a differential equation. And here it is 2y. Okay. We modify this question. Here we write extra y. Okay. Now this, in this question, now here it is y. This y take common and get cancelled. Then we get, it is a minus 1 plus 2v e raised to v upon 2 e raised to v. See carefully this term. Okay. Here we add this y. Okay. In the textbook, the question is only 2 into e raised to x by y. We write here it is a 2y. We modify this question and now we solve this. Here this y take common and this y get cancelled. We get this. It is a minus 1 and it is minus plus 2v e raised to v and upon 2 e raised to v. Now we write this v in RHS. Therefore it is a minus 1 plus 2v e raised to v upon 2 e raised to v minus v. Then take the calculation. Minus 1 plus 2v e raised to v minus 2v e raised to v upon 2 e raised to v. Okay. And now therefore our differential equation it is y dv by dy as it is, and here it is a 2v e raised to v minus 2v e raised to v get cancelled, only minus 1 upon this. That means minus 1 upon 2 e raised to v. Here it is our new differential equation. Now we separate the variables v and y. Therefore we can write it is a 2 into e to the power v dv is equal to minus 1 by y dy. This y dy we can write in the RHS, and here it is a 2 e raised to v in the denominator. We can write in the multiple of this v. Now variables are the separated, taking integral on both sides. Integral of 2 e raised to v dv minus integral of 1 by y dy. Then integral 2 e raised to v is equal to minus log y plus c. Okay. And therefore 2 e raised to v plus log y. Okay. Here v we can put the value of v, that is x by y, and this minus we can write here is equal to c is general solution. General solution of given differential equation. Now we want to find the particular solution when y of 0 is equal to 1. When y of 0 is equal to 1, that is x is equal to 0 and y is equal to 1. Therefore 2 into e to the power 0 upon 1 plus log 1 is equal to c. Then it is a 0 upon 1, it is a 0. 2 into e to the power 0, it is 1. 2 into 1, it is a 2 plus 0. Okay, and therefore 2 plus 0 is equal to c and c is equal to 2. Okay, and then particular solution. Particular solution is 2 into e to the power x by y plus log y is equal to 2. It is a particular solution of this differential equation. Okay. In the textbook, the question is asked only it is a 2 into e to the power x by y. We modify this question and here write the extra y. Okay. Here 2y e to the power x by y, and then we solve this question, we get this answer. Okay. See carefully this.